Hello, in this video of the ADALM2000 series, we'll cover the oscilloscope and signal generator instruments and their features. In order to accurately present both of the instruments' functionalities, we decided to show them together. You can generate signals in the signal generator and monitor them in the oscilloscope. The oscilloscope makes use of the two differential analog input channels capable of measuring signals ranging from -25 to +25 volts at a sample rate of 100 megasamples per second. Naturally, the signal generator is using the single-ended analog outputs of the ADALM2000 at a sample rate of 150 megasamples per second. Plug in your device using the USB connector in the middle, open Scopy and click the Connect button. In the following example, we will generate a sine wave on channel 1 and a triangle wave on channel 2. We will capture these using the oscilloscope. In order to view the signals we generate, we have to connect the two instruments. To do this, we'll make the following connections: W1 to 1+, and ground to 1-, W2 to 2+, and ground to 2-. For better viewing, you can detach any of Scopy's tools in a separate window. Go to the Preferences menu and enable the double-click to detach tool option. In this case, we'll need only the signal generator and the oscilloscope. In the bottom left corner, you can find buttons for each channel's settings. The channels are color-coded, orange for channel 1 and purple for channel 2. From the panel on the right, you can select the signal to be generated on each channel. You can choose between the following: constant for generating constant signals, waveform for generating all the usual waveforms, sine, square, triangle, trapezoidal, rising ramp sawtooth, falling ramp sawtooth, and stair-step. Buffer for loading a signal from a file that can be either a CSV, a text, a WAV, or a math file. Or math for defining a mathematical formula for your signal. You can also add noise to any generated signal. For channel 1, go to the waveform menu and select sine from the drop-down box. Set the amplitude to 5 volts peak to peak and the frequency to 5 kHz. The offset control adds a DC voltage offset to the generated signal. By modifying the phase value, you add phase shift to the signals. Leave the offset and phase as they are. For channel 2, set the waveform to triangle, the frequency to 10 kHz, and the amplitude to 5 volts peak to peak. By pressing the Run button from the Signal Generator tool, you can start the signal generation. In the oscilloscope window, you'll find the plot. The measured signals will be displayed here. You can start the measurement by pressing the Run button. This will start a continuous acquisition. Alternatively, you can acquire a single buffer by pressing the single button. Now you should be able to view our signals. From the panel on the right, you can set the time base, which controls the time interval per division on the x-axis, the horizontal position, the volts per division ratio on the y-axis, and the vertical position. These controls all operate in the same manner. The values can be changed either by pressing the plus/minus buttons or by writing a value in the edit box. When typing a value in the edit box, you can also specify the prefix for the measurement unit as shown. Pressing the center of the range circle toggles between fine and coarse modes. When your mouse is hovering over the knob, you can also adjust the value by scrolling. A drop-down menu is available for selecting the proper measurement unit. You can also change the thickness of the plotted points and the curve style. The memory depth control provides a couple of values corresponding to each time-base value. It increases the number of samples acquired and the sample rate. Probe attenuation control is used to scale the input voltage. Software AC coupling blocks the DC component of the signal. It can be used to see if you have an AC signal on top of DC. It is important to note that this is a software feature, which means there is no hardware coupling involved. The auto set automatically adjusts the offset, range, frequency, and trigger configuration based on the input signals. The oscilloscope should be running when using this feature. The auto set button is grayed out while the oscilloscope is not running. The indexes near the plot can be used to adjust some settings as well. Toggling the orange index allows you to change the vertical position offset for channel 1, while the purple one does the same for channel 2. The blue bottom index allows you to change the horizontal position offset. The blue index on the right side controls the trigger level. We will discuss more about triggers a little later in this video. In the top left part of the oscilloscope window, you can see general information about the plotted samples, such as the buffer size, the sample rate, and the zoom level. You can zoom in any specific part of the plot by selecting it with the mouse. To exit the zoomed view, you must simply right-click. By pressing the General Settings button from the top right corner, you will be able to activate alternative views or export data. You can enable a FFT plot, a XY plot, or a histogram plot. These will be displayed along the plot in the main window. You can zoom in any of these views independently as well. The collected data can be exported to either a CSV or a text file. In the bottom right corner, you can find menus for cursors, measure, and trigger. You can enable cursors by checking the specific checkbox. Cursors allow you to analyze the plot between two given points. When they are active, an information box will appear on the plot. There are vertical cursors for voltage differences and horizontal cursors for time differences. From the cursors menu, you can either activate or deactivate a specific cursor, set the information box transparency, or change its position. Like the name says, the measure menu provides automatic signal measurements. You can display all measurements, or you can create a customized selection of both vertical and horizontal measurements from their own dropdown. You can also enable the statistics and gating features from this menu. The trigger menu provides several trigger options. You can set the internal trigger and set either channel 1 or 2 as source. You can set an analog trigger for a rising or falling edge, or for high or low, and specify its level. The digital trigger can use the external trigger in or the logic analyzer as source. When the logic analyzer is set as a trigger source, the oscilloscope will be triggered when the logic analyzer is. The external trigger in offers the same range of conditions as the internal trigger with one addendum. It can also be set to any edge. The ADALM2000 also provides the option to set an external trigger out. You can choose between the following options: forward trigger in, oscilloscope, and logic analyzer. In addition, the oscilloscope offers some other features, such as math traces, reference waveforms, and the mixed signal view. You may also add virtual channels. We'll cover all these options in a separate video of this series. These are the features of the Signal Generator and Oscilloscope tools. In the upcoming videos, we'll cover the other instruments of Scopy and discuss the more complex features we mentioned in this video. For more resources and information on the ADALM2000 module and Scopy, please visit wiki.analog.com. If you have questions that these videos do not provide an answer to, please feel free to ask us on the Engineer Zone forum in the virtual classroom section. You'll find links to several helpful pages in the video description. Thanks for watching.